Good morning. Today we are doing our last objective of Unit 11, our last objective of the year. This is CO72. I can calculate the probability of compound events. So we're still working with probability. Okay, so all four of these objectives that we're being tested on in this unit are about probability. Okay, now we're going to learn what a compound event is. Compound events are two or more events that can happen either at the same time or one after the other. Independent events are two events such that the occurrence of one event does not affect the likelihood that the other will occur. So independent events, they are separate. They're not dependent on each other. Dependent events are two events such that the occurrence of one affects the likelihood that the other will occur. So let's see what that means. You can find the probability of two events occurring under different circumstances. All right, so let's look at our steps. Step 1. A bag contains 9 pieces of paper. 5 pieces have an O and 4 pieces have an X. You randomly choose a piece of paper from the bag and you get an O. Now this is the key part. You don't put it back. Then you randomly choose a second piece of paper. What is the probability that the second piece of paper has an X? So if we have 5 pieces have an O, 4 pieces have an X. You don't put that O that you draw the first time in. What's the probability that our second one is an X? How do we solve that? Peyton?
Well, 4. So you do 4 over 8 because 4 and 8, like they're 50%.
But there's 9 pieces of paper.
Yeah.
So why am I doing 4 over 8?
Because you took the 5 out. You took one of the O.
Oh, I took an O out and I didn't put it back. So now instead of 9 pieces of paper, I only have 8. So my probability, my total outcomes would be out of 8, not 9, because I didn't put that piece of paper back. So the probability of getting an X is 1/2, or 50%. So it's important to notice that we didn't put that piece of paper back because that affected our total number of outcomes. Instead of 9, now we only have 8 because that O was not put back. So this time we repeat step 1, but this time the first piece of paper has an X. What is the probability that the second piece of paper also has an X? So we want an X the second time. What's our probability of it being an X? Zoe?
3.
Why 3 A's? We had 4 X's to start with, and then we took 1 X out. So instead of having the 4, we had 4 minus that 1 that we took out. So now we're left with just 3 X's out of 8 pieces of paper because we didn't put it back. Landon? No, because we started with 9 pieces. Okay, so we took 1 X out, so we went from 9 to the 8. That was a different one. So we started over again. So we started over again for step 2. Okay, so it said repeat step 1. So the bag contains 9 pieces of paper, 5 O's, 4 X's. So that part started out the same. This time, instead of grabbing an O, we grabbed an X and did not return it. So are these events independent or dependent?
Dependent.
Why are they dependent, Landon?
Because
Nick, why do you think, what do you think?
I think they're dependent because it says in like the dependent events part, it says the two events such as the occurrence of one effect and the likelihood that the other one will occur. You took out one S.
Yes, because we were taking out and not returning, it's making that second one dependent on the first. We couldn't just draw and draw. It was dependent on it because we had taken one away. So those total outcomes were different. Because of the first event, the second event's outcomes were different. So you are correct. Both of them are dependent because we did not return it. So probability of independent events. So for two independent events, A and B, the probability that both events occur is the product of the probabilities of the events. So it's the product of the probabilities, not the event outcomes. We're talking probabilities now. Probabilities, remember, are fractions. So in algebra, we would say the probability A and B is the probability of A times the probability of B. So a coin is flipped and a number cube is rolled. The table of outcomes helps you see the relationship between the probability of the compound events and the probabilities of the individual events. So one is a coin and one is a cube. Are they going to be dependent? One dependent on the other? No, because they're two separate things. We have a coin toss and we have a dice that we're rolling. Two different things. They are independent of each other. So we're going to make a table. We have our heads and tails for our coin, and then we have our dice roll. There are 6 numbers on our dice. Right? So what outcome would we have if we flipped a heads and we rolled a dice? We would put that as heads and a 1. What if we flipped the coin and got a tails and we rolled a 1? That would be a T and a 1. So what if on this column, we're going to have all flipping heads. And on this column, we flip the tails each time. So then what if we rolled a 2? Well, we could have a heads with the 2 or a tails with the 2. We rolled a 3, we would have a heads with the 3 or a tails with the 3. We rolled a 4, we would have a heads with the 4 or the tails with the 4. We rolled a 5, it would be heads with the 5 or tails with the 5. And a heads with the 6 or a tails with the 6. So those are all the outcomes we could have. So the coin is flipped and the number cube is rolled. The table of outcomes helps you see the relationship between the probability of the compound events and the probabilities of the individual events. So now we want to know, what is the probability of rolling or flipping a heads and rolling an odd number? So we know we have the heads is this column, and we have an odd number here, an odd number here, and an odd number here. So what is the probability of the heads? Flipping a heads would be 1 out of 2, right? Flipping heads is 1 out of 2 times the probability of rolling an odd number. There are 1, 2, 3 odd numbers out of 6. So we need to multiply those two together. Real? Yeah. And then we want to simplify it. We can divide a 3 out of both the top and the bottom. 3 divided by 3 gets us 1, 12 divided by 3 gets us 4. So the probability of rolling, flipping a heads and rolling an odd number is 1 out of 4. Does that make sense? Okay. So now what if it's dependent? So independent, you're just looking at the probability of flipping a heads times the probability of rolling that odd number. So we're multiplying the probabilities, not the outcomes. Yesterday we just multiplied the outcomes. Now we're multiplying the probability. So you need to remember that difference. We're multiplying fractions today. Let's scroll up. Now we need the probability of dependent events. So for two dependent events, the probability that both events occur is the product of the probability of the first event and the probability of the second event given the first. So it means that first event's probability, and then we know that bottom number is going to be different, okay, because the outcomes are affected by that first event. So let's see what that means. The 25 fish in your aquarium are 12 loaches, 7 barbs, and 6 tetras. You want to give 2 fish to a friend. You randomly choose 1 fish from the tank and then randomly choose another fish without replacing the first. Find the probability that both are loaches. So what's the probability the first one's going to be a loach? Nope. Remember, our bottom number is going to be the total outcomes. So how many loaches are in the tank for y'all? 12. There's 12 loaches out of how many fish? 25. So the first one needs to be a loach. What are we going to multiply that by? What is the probability that our second one is going to be a loach? And how is that, those numbers affected by that first probability? 11 over what? So, the loach number goes down because 1 loach was taken out already. And then Zoe's right. She first said 25 because there's 25 fish, but wait, 1 loach was taken out. So there's not 25 anymore. There's 24. So both numbers had to go down 1 because there was a loach taken out. So instead of 12, there's 11. And there was a fish taken out. So instead of 25 fish in the tank, there's only 24 fish in the tank. So we need to multiply it through. What do we get? Regan.
132.
We need to simplify that, because that is big numbers. Let me show you what I like to do first, so I'm not trying to find that greatest common factor to divide out and have to simplify till I get to the smallest. I'm going to go right here and I'm going to cross simplify. I can divide a 12 from 12, and I can divide a 12 from 24. So I'm gonna have 1 over 25 times 11. 24 divided by 12 is 2. So if I cross simplify first, I know my greatest common factor is that 12. So then I can say, okay, 1 times 11 is 11. 25 times 2 is 50. So if I took 132 and I divided it by 12, I would get 11. 600 divided by 12, I would get 50. So that was simplifying made easy, because you want your final answer to be as simplified as you could get. I could look at 132 over 600 and say, oh, they're both even, I'm going to divide by 2. And then I would have to divide by 2. And then I would have to divide by 2. So it just makes it a little easier for that simplifying.
My calculator, I got 86. So, do I have to write it out or do I just do it?
Well, you have to show me your problem. So you would have to show 12 over 25 times 11 over 24, and then give me what the answer is. But do you have to show your work? You bet. So even though you're typing it into your calculator, you still need to show what work you're doing. So that way, if you get it wrong, we can see where you went wrong. So you always, always, always have to show your work, because sometimes we accidentally add instead of multiply. We make simple mistakes. We punch in the wrong number in our calculator. Always show your work. So big thing to remember. These are probabilities we are multiplying today. So fractions, we're multiplying those fractions. Second big thing to remember, if it's dependent, the numbers go down. If we take out a fish, the number of fish goes down. Okay, you have to pay attention. Is your first event affecting your second event? They are two separate things, like the flipping a coin and rolling a dice. They're independent. They don't affect each other. Just multiply the probabilities. Let's look at our homework for today. Yes.
I have one quick question. I can't really remember this.
So let's look at our assignment for today. We just have to tell for 1 and 2, are they independent or dependent? Does our second event, is it affected by that first, or are they two separate things? Then for 3, 4, and 5, you need to figure out what the unknown probability is. So they are independent events. So for number 3, you know the probability of A and B. Oh, hold the phone. They didn't give us fractions. What do I do? Why are there decimals? Decimals are the fractions. 3/8 you can divide down into a decimal, right? 3 divided by 8. So we have to multiply the probability of 1 by the probability of 2. So we can multiply our 2 decimals. 0.7 times 0.2 to find the probability of both. What are we going to do for 4? If we know the probability of both is 0.15, and we know one probability, what math do we have to do? Yes, Zoe. So for number 3, we did 0.7 times 0.2 equals A and B together. Here we know that A and B, and we know the A, but we don't know the B. So we need to divide both sides by that 0.5 so we know what the probability of B is on its own. Does that make sense? Think about your equation. Put in the numbers. So we know our equation is the probability of A times the probability of B equals the probability of A times B. So you're going to fill in your known numbers and solve for the unknown. For numbers 6, 7, and 8, these are dependent. So probability of A, the probability of B given A, and them both. So you're doing the same math. Same math. Okay, put it into your equation and solve for the unknown. On the back side, try to figure it out. See if you can find the probability that both events A and B will occur. You need to decide, are they independent or dependent? What is your probability of A, the probability of B, and then the total probability of A and B. With that, we're going to tell our friends at home that we hope you are well and we hope to see you soon.